Hi, welcome back to another video, again in quadratic function. It says, let f of x be x squared minus 4x plus 3 for every x belonging into the real set. It says A, for the graph of y equals f of x, find the y-intercept and the x-intercepts. And then on B, it says a function f can also be expressed in the form vertex form. Find the value of h and find the value of k. Okay, so we're going to go step by step. The first step would be, if I'm being given the standard form f of x, I could do the following. Okay, so I'm going to do it in, I'm going to write it down underneath. I'm going to do it in, whoa, I'm sorry. Whoa, what happened? Okay, so I'm going to do it in several steps. Okay, and they're all different from each other so that you have all possible tools to reach an answer, okay, reach an expression that's going to comply with what you're being asked, but also to provide alternatives, right? The beauty of math, as I always say, is that there's not a single way to do everything. Okay, so the first one is pretty straightforward. We have a y-intercept whenever x is 0. So all you have to do is find the image of 0, right? Plug it in other words. And that is to evaluate 0 in the function, and you get 3. So in other words, we're talking about 0 comma 3 being our y-intercept. Okay, and then they're asking for the x-intercepts. Okay, and I'm going to write it over here. The x-intercepts happen when the function is equal to 0. So in other words, we're taking our function f of x squared minus 4x plus 3, and we're substituting f of x for 0, and that's a quadratic equation. Okay, for people that know the discriminant is going to be the value of b squared minus 4 times ac. In this case, our a value is 1, our b value is -4, and our c value is 3. Meaning that when you do b squared minus 4 times ac, that's going to be -4 squared, 16 minus 4 times 1 times 3, that's 12. 16 minus 12 is 4. Square root is 2. Now, why is it important to take out the square root? Because it allows you to know if this is going to be factorable or not. Okay, and so within the rational numbers, I'm sorry, I have to say that, within the rational numbers. Now, factoring this expression, right, you look for two numbers that multiplied give you 3, right? And that added together give you 4. Okay, so two numbers that multiplied give me 3 and added together give me 4. That's going to be -3 and -1. Okay, using the zero product property. The first factor may be equal to 0. That means x is 3. And the second factor equal to 0. That's going to be 1. And so my x-intercepts will happen at 3 comma 0 and at 1 comma 0. Okay, now the second part says, well, you can take this function and express it in the vertex form. Okay, now please look and be very cautious in this case. See how they're telling you that a is 1? We already knew that a was 1. Okay, and so that makes things just a lot more simpler. And as I promised, I said I was going to be doing two different ways. Okay, one is called the completion of completing squares, and the other one is using an approach that may work. It's also very simple to do it. So completing squares says you can take that x squared minus 4x plus 3 and then just complete the square, right? So square root of x squared is x, and then what we do is we halve the value of b. Okay, and so the value of -4 is -2. We bring down the c value. We bring it down. See how it's +3, and then we always subtract this number squared. Okay, so whatever number you got as half of b, that's going to be -2 squared is 4, right? Even though I know it's -2 squared is 4, we always subtract that value. Okay, and so I'm going to put it in red because you have to be aware of that. And then finally, you get that x minus 2 squared, and then positive 3 minus 4, you combine those terms, those are like terms, you get a negative 1. And so this is your function using completions of squares, or completing squares, I'm sorry. Okay, so that's one way to do it. The other way to do it is, well, you know that when you have the standard form, you could find a vertex or axis of symmetry doing negative b over 2a, right? So if you find the axis of symmetry, that would be negative 4 divided by 2 times 1, that's a 2. And when you simplify, your axis of symmetry is 4 divided by 2, which is 2, okay? Now remember, this is the axis of symmetry. This is what we call the h value, okay? So again, you have the h already. Now you need the k value, okay? So I'm just gonna write here for h, this is what you do, okay? H is the same thing as negative b over 2a, the axis of symmetry. And then for the y value, right? For the k value, if you wanted to, you could have also said, okay, so the y value is, I'm going to evaluate that here, okay, in my function. Knowing that x is 2, this is a simple function to evaluate, right? So it's negative 4 times 2 plus 3. And then you do the math, the arithmetic. This is going to be 4 minus a plus 3. That's negative 1. If you're asking yourself why I'm putting that v, it's because I'm used to talking about the k value as the y coordinate of the vertex, okay? So once you have that h value and you have that, let me write that down, that k value, where did black go? My function is going to be, I'm sorry for the noise outside. My function is going to be x minus h, right? So h is 2 squared, and then plus k, it's going to be minus 1. And as you can notice, this is the same value. Okay. And then there's this final one that I wanted to show you guys. And it's the y vertex, the y coordinate of the vertex. Could also be calculated in the following way. Like you could say it's negative discriminant over 4a, okay? And so I did this mentally, but I'm going to go ahead and show it to you. So negative discriminant is just doing 4ac minus b squared divided by 4 times a, okay? This would be, let's go ahead and evaluate all the values. Minus, and this is negative 4 squared divided by 4 times 1. And as you can see, this is going to be 12 minus 16 divided by 4. This is negative 4 divided by 4. You also get negative 1. So this is another way in which you can find a k value. That's very useful. Okay, I hope you liked this video, and please click on like if you did.